Okay, so I'm going to do an experiment with polarizers that will explain some ideas about vectors that we have been talking about. So first of all, I need a laser. Hopefully you see on the wall this green light. Okay, that's for the laser. And then I'm taking a polarizer, which is this thing that you see here. You can get these on Amazon like for $5 if you want to play around with this. And so I'll take the polarizer and I'll just turn on the laser. And well, as you might imagine, after if you can see, I don't know how well you can see the details, but essentially what happens is like maybe the strength of the laser decreases a little bit as the light goes through the polarizer, but nothing major takes place right now. Okay, so again, this is my hand and then the laser. Now what if I take a second polarizer? So I'll leave the first one where it is right now. I'll take another polarizer here. I'll try to put it in a somewhat strategic position. I'll explain why I'm choosing it the way I'm doing it, but I'm just going to place it after the first one. So now the laser has to go through two obstacles. Okay? And maybe it would be useful if I turn out the lights a little bit. I don't know if this makes it better. I think it does. So with one polarizer, this is what you see. And now I'm putting a second polarizer, and essentially if I do it carefully, well, at least you will agree that the signal depends on how I move around the laser. The signal diminishes significantly, right? So I'll keep it this way, but you should just think that the effect of the second polarizer is to decrease the signal, like the light on the wall. If you do this very carefully, you can actually choose things in such a way that you don't see anything after the second polarizer. But for us, we'll be happy just with this diminished signal. Okay. But now, what if I'm going to take a third polarizer and I'm going to put it in between the two polarizers. So the question is, what should happen in that case? Well, if you think of the polarizers as some sort of walls that are somehow diminishing the strength of the laser, well, if already with two walls the signal is pretty dim, you would imagine that with the third wall, right, it should be even less. So we should not see more, right? And so let's try to see what happens. So again, this is after having two polarizers. You see something, a little bit of green light at the wall, and now I'm going to place this one in the middle. And I don't know if you see the effect, but when I insert the one in the third polarizer between the original two, if I do it correctly, you should notice that sorry, I need to do it more careful. You should basically see that there's a slight, maybe I should do it here. So this is after two. I don't know if you noticed that depending on how I orient it, you can actually see that the strength of the signal or the laser increases by a lot, right? So what I will do next is explain to you why this is happening. It's an unfortunate thing that you are seeing in my hand. Maybe let me see if I can put it on the other side. Well, you should buy a polarizer on Amazon and try it yourself. But I'll do an explanation using vectors or what's going on. But again, you should still find this somewhat striking because you have inserted like a third obstacle, and somehow if you choose it correctly, you can make more of the signal reappear. Okay, so here's an explanation of what's going on in the experiment I just showed you. Well, this is more or less a toy model, so probably there are more subtleties going on. But one way to think about it is that you can imagine that the light is characterized by an electric field. Okay, E. Let me change the color of the paper. And then the polarizer, what it does is select a specific component of the electric field. So by that I mean, let's say you have the first polarizer, the polarizer P1, and well, they are called like linearly polarized, and so that means that they would select, they come with a preferred direction in space. So let's say the preferred direction in this case would be this one. And so what the polarizer will do is project the component of the electric field along the direction specified by the polarizer. So what that means is that you would take, you will copy the electric field here, and then the projection of the electric field along the first polarizer is the stuff that goes through. And so you see in this case, well, what will happen is that there's some of the vector remains, and this is what you see on the screen. You should really think maybe that the light does not have a specific, the electric field does, like there are many, like it's random, the electric field of the light maybe is changing randomly, so it's not that there's just like a unique vector attached to the light. But if you look at a particular situation, this is what's going on. Okay, and so once you introduce a second polarizer, if you notice what I did, I had to play a little bit with the second one. Let's say I had to play a little bit with the second one in such a way that essentially the directions each polarizer singles out in space are perpendicular to each other, or almost perpendicular to each other. And so again, when you run the same experiment, if you looked at a specific vector, after the first polarizer you get that component that you saw here, but now you have to project this vector into the second polarizer, and well, since there are 90-degree angles, you don't get anything, you get a dot. And this is why in the video almost everything went away. On the other hand, when you put the one in the middle, the idea is to do it in such a way that the third direction that is singled out is somehow at an angle with respect to the other two polarizers. So that again, now what you get is something like where this one survives the first, this is what survives the first polarizer, but now there's a component of this vector along this other vector, which will look maybe like this. Well, maybe the vector should be shrinking because you're projecting, but that's not the point. The point is that the directions in space that you're getting. But now when you take the new vector with respect to the final polarizer, you see now there's some non-trivial shadow, and that's what survives. So this is why when I inserted the one in the middle, you get to see some light and in the end. This is like for classical, like say electromagnetism experiment, there's a quantum version of this if you want to Google it, but where something similar is going on.